Raj, I got your doubt. This is your answer.
Vedantu. Learn live online. To attend a free live class, download the app now.
Hello everyone. Good afternoon. Hi Shreya, Swatantra, Nikhil, Shilpa, Naman Singh, Janvi. Tell me, how are you all doing? All good, happy, making the steady days awesome and chill, rocking. So many words, right? Jai Mataji, I don't know what is it. So I forgot to tell you that happy Valentine's Day. So I hope you are having it. You are having such a lovely day, and I hope you have wished most important people in your life. I hope. I'm all good. Okay, thank you so much for asking, Kushi. Okay, so instead of asking how are you, from now onwards I'll be asking you kaisa hai sab log, because I'm also started learning Hindi, so slowly I'll make it more and more better. So what will I be asking? Kaisa hai sab log. So just like me learning Hindi, I hope you guys are also learning physics from me a lot, not a bit, a lot. I hope you guys are learning, right? And thank you so much, Anjali. Okay, happy Valentine's Day to you all. Okay, and for those who don't know me, myself Ameer Sir, master teacher of JEE Physics at Vedantu. I did my BTech from NIT Calicut in mechanical engineering, and I am now with you all guys to learn something from you, to teach you something and make the day and all the sessions awesome. So okay, what happened? Why some Dibangur is asking, please sir, what happened? Okay, we'll start. Okay, we'll start. So let me brief you what we are going to do today's session. In today's session, as we all know, we are here for the 12th board sprint to discuss ourselves the previous year questions. So we have done enough chapters. I hope you have understood all those chapters. Those who have missed all those questions and previous year questions and the concept of all these chapters, don't forget, it is still available in the YouTube. It will always be available. You can type my name and the topic's name, and what the topics which is left are dual nature, nuclei and semiconductors. And on today's day, which is 14th of Feb, we'll be discussing which topic are we going to discuss today? One of the beautiful, simple and easy scoring chapters, dual nature of matter and atoms. Okay, so these two chapters we'll be discussing. So guys, are you all ready to start with the first question and to make the session very super awesome? Right? All good, happy? Tell me yes or no. How to be first in class 12 boards? There is nothing like first or second because there is no ranking, but you can compete yourself to get a mark above 95%, right? Thank you so much, Satantra Gaudam, for telling me that I look so handsome. Okay, so I know that for some of you people the topics will be so tough, so some particular chapters will be more tough. For that, Vedantu is there to help you guys. If you can give 1 rupee, just 1 rupee, okay, you can get whatever courses between whichever chapters you are lacking. So you can buy it just for 1 rupee. So come visit the Vedantu website, buy your courses just for 1 rupees from your required teachers, and it will help you a lot, means a lot. Okay, Vinita, thank you. So shall we start? Are you all ready? We have the first question just in front of us. Tell me yes or no. Josh is high. Everyone, okay, we'll keep away the Valentine's Day. So let's talk about physics now, then we'll talk about love and all those things after. Yes? Okay, very good. Here comes the first question. Draw graphs showing variations of photoelectric current with applied voltage for two incident radiations of equal frequency and different intensities. Okay, and mark the graph for radiation of higher intensity. So the question is about the graph has to be plotted between what and what? Between the potential difference between the emitter plate and the collector plate and the current that is being produced, photoelectric current. So I'll just brief you what is this photoelectric effect with the figure, right? Okay, so listen. So what do you mean by the photoelectric effect? First, the basic thing, the emission of the electrons from the metallic plate if it is incident with light of sufficient frequency or energy is called as photoelectric effect, right? Okay, so I'll draw a small figure to explain this particular process. So two plates you have, one is connected to negative, other is positive. So here it will be like a small opening will be there. Look, a small opening will be there so that the light can come and fall on it. Okay, so what happens when a light of sufficient frequency come and falls on this plate, which will be calling it as the emitter plate and this as the collector plate? What will happen if you place a galvanometer over here? You can see a deflection in the galvanometer. What is happening when the light of sufficient frequency or energy comes and get incident on this emitter plate? The electrons will absorb the energy which is present in this metal and it will be emitted, and this emitted electrons will be moving towards the collector plate because collector is of what potential? Positive potential, right? So this is the basic process, which means the energy given by this particular light is used for two purposes. One is to give the energy for this electron to come out of the attractive forces in the metal. Okay, then the remaining energy from the energy which we have given is used for kinetic energy of the electrons. Understood? Whatever energy we give, two purposes. One is giving the energy given to the electron to come out of the metal, which is called as a work function, and the remaining is given for the kinetic energy, right? Okay, all good. So the question is about plotting a graph between what and what? Plotting a graph between the potential on the collector plate, right? Okay, so with applied voltage for two incident, with applied voltage and the current. So here I am marking as the voltage of which plate? Of the collector plate, voltage of collector plate, and here you have the current. Look, think that because of the light's intensity, what do you mean by the intensity? Number of photons per unit area per unit time. So if 10 photons are coming, 10 electrons will be emitted. Okay, from the emitted 10 electrons, initially if the collector voltage is 0, think that 5 is coming. Okay, 5 is reaching the collector plate, so the current is produced because of the 5 electrons, right? Whenever the potential of the collector plate is 0, you have current because of 5 electrons. Now what you are doing? You are increasing the value of potential of the collector plate. So what will be happening? Instead of 5, 6 electrons, 7, 8, 9, 10 will come. After 10 number of electrons, if you still increase the potential of the collector plate, is there any more electrons to come at that particular moment of time? No, right? So initial cases, when the voltage increases, current will increase. After some time, the current will be the same. Understood? And this maximum current is called as what? What do you call this current? You call it as the saturation current in that particular case. Okay, understood? Okay, now instead of making this collector as positive, what am I doing? I am giving negative over here, right? What will happen if you give negative potential to the collector plate? Okay, electron has to come and reach over the collector plate, right? Okay, so if the electron has to come and reach over here, and if you give negative, what will it do? It will try to oppose or decrease the value for kinetic energy, or less number of electrons will reach over here as you increase the negative potential of the collector plate. And after some time, if you keep on increasing, no electrons will be coming, okay, at a particular value of voltage, and that voltage is called as the stopping potential. If I increase the negative value of the potential, the electrons will be having a repulsive force, so less number of electrons come, current decreases. After some time, for a given value of potential, which is called as a stopping potential, no electrons will be reaching this collector plate and the current will be 0 at that particular time. Understood? Okay, all good. This potential is called as the stopping potential. Okay, now the graph has to be plotted for two different intensities with the same frequency, right? Yes or no? So if the intensity increases, what will be increasing? The number of photons increases. Number of photons increases, what will increase? Number of electrons increases. If number of electrons increases, what will increase? Current will increase. So if a graph is plotted for different intensity, what will increase? The current will be increasing. So you can draw the graph like this. But will there be any change in the stopping potential? Will there be any change in the stopping potential? Who is going to tell me? Barrier potential is different, okay? It is not at all concerned with this chapter. So will there be no it is, the answer is no. Very good, Rajni, Devanand, Ujjwal. Okay, why it is no? Because if the stopping potential has to be increased means the kinetic energy of the electrons has to be increased, right? Okay, if the kinetic energy of the electrons has to be increased means more number of energy has to be given by the incoming light. If the incoming light's energy has to be increased means frequency has to be increased, because energy is equal to h nu. But in this particular case we are providing only same frequency. As the frequency is same, the stopping potential will be the same. So we'll be drawing the graph like this. As the intensity is more, the current will only be increasing, but the stopping potential will be remaining the same. Understood? All good, happy? Anybody is having any problem till here? I hope no, right? Understood? So I think I tried to explain this photoelectric effect in a brief manner. I hope you all understood and enjoyed it. Say yes or no? Yes? Good? Happy? Okay. Doubt? What is the doubt? Okay, shoot the doubts. If someone is having any doubts, you can tell me now. So what is this yes and no? Can you tell me? What is this yes and no? People who are telling no, does it mean that you guys haven't understood? No problem? Okay. So I hope no means no problem, yes means you guys have understood, right? I'm going to take it as such. No doubts, right? Okay, very good. Great. So next question. What is the next question? Very simple question it is. A proton, okay, and an electron have same kinetic energy. Okay, the kinetic energy as the same. Which one has greater de Broglie wavelength and why? Okay, so we are asked to make a connection between the wavelength of what and what of the proton and the electron, right? So as it is given that the kinetic energy is given same, we have to make a relationship between what and what. We have to make a relationship between the de Broglie wavelength and the kinetic energy, right? So many are telling me the answer already. Janvi is telling electron, Sushant is telling proton, Devanand is telling electron. So let's see whose answer is correct. And Amar have told electron 3 times. Okay, so let's see who is going to win this particular game. Okay, so the de Broglie's wavelength formula. What is de Broglie's wavelength formula? Lambda is equal to h divided by p, where p is equal to momentum, right? I hope nobody is having a doubt in this particular question. It's a direct question where no derivation is there in your NCERT book also, right? Okay, now the momentum and kinetic energy relation. Who is going to tell me the relationship between momentum and kinetic energy? Make it fast. Momentum and kinetic energy relation. Nobody. Give me the answer very fast. Big chocolate for who is going to tell me the answer. Root of 2m into kinetic energy. Very good, very good. So momentum is equal to root of 2 times mass into kinetic energy, right? So I'm going to substitute it over here. So lambda is equal to h divided by, instead of p, I'm going to write root of 2m into kinetic energy, right? Okay, now we are asked to find out the relationship between their wavelengths, and as h is a constant, kinetic energy is also a constant. Lambda is inversely proportional to the root of mass of the particles, right? Okay, I'll give you big chocolate. Okay, Shilpa, don't worry. Send me your address. I'll send you the big chocolates. Fine. So which means whichever is having larger mass will be having lesser wavelength, and if you want to find out the particle with greater de Broglie wavelength, greater wavelength will be having lesser mass. So among the proton and electron, which one has lesser mass? Among the proton and electron, which one has lesser mass? Very good, very good. It is electron. So what is our answer? Our answer is electron, right? So those who got electron, or those who have told the answer is electron, your gifts are on your ways. Okay, so you'll soon receive the gifts in your home. So whatever gifts you are going to receive today, just think that it is because of me, not because of your Valentine's friend. Okay, so all the gifts is from my side. All good, happy. Hi Shilpa. Okay, you are Naithili. Okay, good. Imaginary gift, not imaginary gift. Of course, as it is Feb 14, you will be getting a gift. Okay, so and it's from my side. Okay, hi Brajwell. All good, happy? Jayant, next question. So let's not waste our time. Define the term stopping potential in relation to photoelectric effect. What is stopping potential? As I was explaining in the previous figure, if you want, I'll draw it again. So here you have the thing, right? So here you provide negative and positive over here, and whenever light comes and get incident on this emitter plate, electrons will be emitted with some kinetic energy. If the incident light is having an energy greater than the work function, where work function is called as the minimum energy required for the emission of electron from the plates, right? Okay, so the electron which is emitted out with some kinetic energy will be attracted if this plate is having positive potential, right? Because electrons are always attracted to positive. Suppose think that instead of positive over here, I'm giving a negative charge. Okay, so I'm giving a negative charge. So this is the graph between the current and the potential, just like we have drawn. If it is zero, nothing, if the potential of this collector plate is zero, means nothing is there to attract, nothing is there to what? Repel also. So some of the electron which is having enough kinetic energy will be reaching over this plate and producing a current. Once I start to give negative over here, what will happen? Once I start to give negative over here, what will happen? The electrons will be facing a repulsive force, right? And what will happen? At that particular moment of time, if the negative potential is at this moment of time, some of the electron which is not having necessary energy will not be reaching here, so the current will decrease. So if the potential is over here, current will decrease. Again, if the negative potential is increased, current decreases. After some time, for a particular value of potential, no electrons or even the highest kinetic energy electrons won't also be reaching this collector plate. If no electrons reach the collector plate, will there be a current in the circuit? No. So the current will become zero at that particular value of potential, and that potential is called as the stopping potential. Just like the name states, it is a potential given to the collector plate to stop even the highest kinetic energy electron, or to make the net current in the circuit zero, is called as a stopping potential, right? Yes, I'll explain the Einstein equation. We have a question regarding that. Okay, but Prajwal, don't worry at all. So got till here? Everyone? Guys, understood or not? Those who have understood, give me a yes or type the word as understood so that we can move to the next question. Okay, all good? Happy with a smiling face, right? Yo, love you sir, thank you so much, Sakshi. Okay, great. Next question. So just like this, if you guys are having any doubt, so Vedantu is having a platform where all the students will be benefited, where you don't have to pay anything. What you want to do, just download the Telegram and join the Vedantu group by using the link over here. And if you are having any doubts, all the fabulous teachers of Vedantu are there to help you guys. So it will be so much helpful if as you're preparing for your board exam and JEE mains, right? So if you guys are really want to do that, you can do it. Okay, fine. So next question. A similar kind of question based on where we have explained the theory. An alpha particle and proton are accelerated from rest by the same potential. Okay, the potential difference by which the electron and alpha particle is being accelerated is the same. Okay, find the ratio of the de Broglie's wavelength. So if you want to make a ratio of wavelength, we want to find out what is the relationship of this wavelength with the potential, right? So are you all ready? It is not 1:1. We will see. There is a small difference there. In the 1:1 question, the kinetic energy was same, right? Here the potential is same. So let's see what is the difference that is going to make in the answer, right? Very good. Let's see. What happened? One minute, guys. Okay, so I'm sorry, there was a small technical error. I hope you guys are fine. So shall we start with the question? Okay, so the de Broglie wavelength formula, lambda is given as how much? Lambda is equal to H divided by P. Right? Okay. So as we have already told you, P is equal to, how is the relationship with momentum and kinetic energy? 2m into kinetic energy. Now, who is going to tell me what is the relationship between kinetic energy and the potential? What is the relationship between kinetic energy and the potential? What is the relationship between kinetic energy and the potential? Very good. Kinetic energy will be equal to QV. QV is this one, right? Potential energy. How the potential energy is equal to kinetic energy? Does anyone know that? Does anyone know why it is so? Because when the electron is getting accelerated from the emitter plate to collector plate, what is decreasing? The potential energy is getting decreased, and that decrease in potential energy is actually converted as the kinetic energy. That is the reason why we are writing kinetic energy is equal to Q into V. Okay, all good. Yes, work energy theorem, if you want. It is not work energy theorem though, it is conservation of energy, you can call it, right? Okay. Okay, Purva, I know your actual name is space scientist. All good. Welcome to the class, Purva. Okay. So H divided by root of 2m into kinetic energy, just like I told you, to root of 2m into kinetic energy is equal to Q into potential. So lambda is equal to H by root of 2m Q into V. H is a constant for both of the cases, which means alpha and proton. V, the potential is also the same. So lambda is proportional to inversely proportional to root of mass and charges Q, right? Okay, very good. So what is the question? Ratio of de Broglie wavelength of alpha particle to lambda of proton is equal to inversely proportional to root of mass and the charges. So it will be root of mass of proton into lambda of proton, okay, mass of proton into charge of proton divided by mass of alpha particle into charge of alpha particle. I hope nobody is having any doubt in this particular case, right? Okay. Now root of mass of a particle is equal to 1 proton, right? Okay, so I'm writing it as P. The charge of 1 proton is also 1 Q divided by mass of alpha particle is equal to the mass of 4 protons, right? Because the mass number of alpha particle is 4 times. So 4P into charge of alpha particle is how much compared to proton? It is 2 times. So I'm going to write it as 2Q. So this is 1 by root of 8. What is 1 by root of 8? Understood? Or you can take it as root 8 is equal to 2 root 2. Happy? Shilpa? Then Anmol, Prajwal. Okay, sure Prajwal, I will explain you this Einstein concept, don't worry at all. Okay, there is a question which is coming, I'll explain you. Without explaining I won't go. Okay, someone is asking how kinetic energy is equal to QV. What is QV? Potential energy, right? Okay, so look, 2 plates are there, right? Whenever an electron is moving from here to here, the potential energy is actually getting decreased. Okay, potential energy is actually getting decreased because it is the electron which is moving. Electron is having a negative charge, so the potential energy is getting decreased. So that decreased value of the potential energy is getting converted as the kinetic energy. So kinetic energy is equal to change in potential energy is equal to QV. That's how. Okay, very simple, right? Good, happy. Next question. Rajiv, you will rock in CBSE. Wow, that's a good thing. So I hope that's a motivation for everyone, and I hope everyone is going to do that. Yes, we can say potential energy is equal to QV, right? Yes, potential energy is actually equal to QV. V is a potential difference into charges, potential energy. NCERT and previous 10 years is, yes, that is more than enough. Yes, guy. Okay, Shilpa is also there. Hit a like for our handsome Ameer Sir. Yes, please hit a like button and subscribe button also. So next question, are you all ready? Janvi, okay. Thank you so much, Janvi. Next question. Okay, so here comes the next question. Look, Prajwal, your question came over here. Look, I'm going to explain it. I hope you are there. Prajwal, you went away or what? PK Verma, PDF. Okay, let me try to share it with you. Okay. Now, question. Write Einstein's photoelectric equation. Then after writing, what we have to do? State clearly the three salient features observed in photoelectric effect, which can be explained on the basis of the above equation. Right? Okay. So everyone might be knowing the equation, right? So let's learn how that equation is coming. Look, supposing that with the same figure what we have already drawn, when a light of sufficient energy E is coming, okay, a light of energy E is coming over here, and this energy E, look, what am I doing? This particular energy E is given to the electrons. Okay, so the total energy available to the electron which is present in this metal is equal to E. So what all purpose does it use it for? The electrons, the first purpose is to come out of the attractive forces which is given by the nucleus, right? This electron which is present in the metal plate is being attracted to the nucleus, and if you want to take that electron, you want to give some minimum amount of energy, that is called as a work function. So from some amount of this total energy what we give, some energy is used to take the electron out of that attractive force which is called as work function. Okay, suppose the given energy, if it is more than the work function, what will we use the remaining energy for? What will we use the remaining energy for? We will be using, now the electron is out, if you give the work function, the remaining energy will be used to give the kinetic energy of the electrons. Understood? It is used for, very good, Amar, Arushi, Prajwal, very good. It is used for giving the kinetic energy of the electrons. This is called as the kinetic energy of the electrons. Understood? So this is our Einstein's equation. And if the frequency of the incoming light is nu, how will you write the total energy? H nu is equal to, if the work function or the minimum frequency which is called as threshold frequency is nu naught, how will you write it? H nu naught, right? Plus kinetic energy, how will you write? If the stopping potential is equal to V naught, kinetic energy is equal to decrease in potential energy, just like I have explained you, that is QV naught, right? All happy? So this is the equation. So they are asking what all things can be explained from this equation. The first thing that can be explained is, if you want to increase the kinetic energy of the particle, what has to be increased? The total energy what is given by the light has to be increased, or the frequency of the light has to be increased in order to increase the kinetic energy. And you can also say intensity doesn't have a role in this. That is the first part. Next one, what can you say? The given energy, this should be greater than h nu naught, which means the work function. Else what will happen? Else the emission of electrons won't be happening, as the incident light is not having the minimum energy to take out the electrons from the metal, right? Okay, so that is the second thing that what you can get from the equation, which is Einstein's photoelectric equation. Yes, very good Arushi, very good, very good. So understood till here. Menti quiz we will be doing in the next time. This is just for the board exam, right? Okay, all good, happy till here. Everyone understood? Give me a yes or no. Prajwal, where is Prajwal, the one who asked for explaining? Okay, thanks, which says I hope you understood. Weightage of this chapter, you will be getting a question of almost about 10, and in between 10 and 15 marks you will be getting a question from these three chapters. Okay, happy? Wave optics and ray optics we have already done, just like I told you. It is still available. My class is still available in the YouTube. You can search it in the YouTube and you will find out that ray optics, wave optics, all the chapters are being done. Next question, I hope nobody is having a doubt on this. Calculate the shortest wavelength of the spectral lines emitted in Balmer series. What is the question about? Shortest wavelength of the spectral lines. Now, what is happening, or when will the spectral lines or the spectrum will be obtained? Look, I'll give you a brief explanation of the spectral lines and spectrum. Look, if you are having that, this is the nucleus, and think this is the nucleus of hydrogen, which means one electron will be there in the protium. So this is shells, first cell, second cell, third cell. If the electron is in the third shell, and you know that the energy of the orbit increases as you move away from the nucleus. So the energy of this electron is obviously high. So what will it do? As it want to attain stability, it will try to decrease the energy so that it will be coming to its lower orbits. So when it comes to lower orbits, energy as it is decreasing, as it has to be decreased, it will be emitting out energy. So this emitted energy will be coming out as the spectra. This is called as the emission spectrum, right? Okay, so some of the energy which is being emitted by this particular electrons will be in the visible region, or the wavelength of the spectrum which is being released during the electron transmission for some of the transitions will be in the visible region, and that kind of series obtained is called as the Balmer series, right? And when can you see this? If the electron transition is happening from any of the orbits to the second orbit of that particular atom, then you can see what kind of series? Balmer series, or the spectral lines in the visible region. Understood till here, everyone? And the equation to find out the wavelength emitted for the Balmer series is equal to 1 by lambda is r into 1 by 2 square minus 1 by n square, where n is greater than 2. Which means it can come from third, fourth, fifth, sixth, seventh, eighth, from wherever it comes. If it is coming to second, the light emitted or the spectrum emitted will be in the visible region. Understood till here? Okay. Now they are asking to find out the wavelength, but they are asking for the shortest wavelength. If the wavelength is shorter means, what it has to be? The energy has to be greater, right? Because energy is equal to h nu and frequency nu is equal to c divided by lambda. As lambda is inversely proportional to energy, if they are asking for the shortest wavelength, it is equivalent to find out the highest energy transition. Where can you find out the highest energy transition in the Balmer series? If it is coming from third to 2, or if it is coming from fourth to 2, or if it is coming from infinity to 2. Where can I find? Who is going to tell me? From where can you observe the maximum energy for the spectrum obtained in the Balmer series? Right? It is from infinity. Very good. It is from the infinity, because the energy difference is more, right? If the energy difference between the orbit is more, it is the energy difference between the orbit is actually emitted as the energy of the photons, which means if the energy difference between the orbit is greater, what will also be greater? The emitted energy will also be greater, or the energy of the photons will also be greater. So if it comes from infinity, you will have the maximum value of energy or minimum value of wavelength, which means this n has to take a value of infinity. So 1 by lambda is equal to r into 1 by 2 square is 4 minus 1 by infinity is 0. So 1 by lambda is that. So lambda is equal to 4 divided by r, that is 4 into r is equal to 10 power 7. It goes up into 10 power minus 7 meters. Understood? Small question, right? Or you can write it as 400 nanometers also. Those who want to write, okay, Sairaj is telling 400 nanometer. Yes, good. Not Armstrong, nanometers, right? Your physics is very weak, so you have to improve it. You have to learn the concept. You can go through all the videos which is still there in the YouTube. That will give you an idea how to deal with the chapters and all those stuffs. Okay, Arushi? All good? Happy? So next question, as it is waiting for us for a long time, let's do it. The equivalent wavelength of a moving electron has the same value as that of a proton of energy 6 into 10 power 17. Calculate the momentum of the electron. What is given? Wavelength of an electron and a proton sorry, not a proton, photon. Okay, so wavelength of an electron and a photon is the same. So we will write here wavelength of the photon is equal to wavelength of the electron. And the question is about the momentum of the electron. What is the formula for momentum of the electron? H divided by lambda. Lambda of what? Lambda of the electron. As electrons lambda and photons lambda is same, you can also write H divided by lambda of photon, right? Okay. In order to find this, a hint is given in the question. What is the hint? The energy of the photon is given as how much? 6 into 10 power minus 17. Energy of the photon is 6 into 10 power minus 17, right? Okay, how will you write the energy of photon? H into nu of the photon is 6 into 10 power minus 17, right? Nu can be written as H C divided by wavelength of the photon is equal to how much? 6 into 10 power minus 7. Yes or no? What we want to find out? H divided by lambda p, which is the momentum of the electron. So here you have H by lambda p. So H divided by lambda p is equal to 6 into 10 power minus 7 divided by c. Velocity of light in vacuum is 3 into 10 power 8. So how much it is? How much it is? 3 2s are 6. So 2 times then into 10 power minus 15 is the momentum. Okay, formula for momentum is equal to what? Momentum is equal to mass into velocity. So kilogram meter per second. Happy? Very good, very good. So many already gave me the answer. It's a great thing. Adarsh, Maitri, Janvi. So happy everyone? Yes, I have already explained, sons. Okay, we have explained in the 2 questions before. So guys, how was the class? About the atoms and the remaining chapters, we'll be doing it tomorrow. Happy? Best. I hope everyone have understood the topic, whatever it was being taken. Awesome. Thank you so much for all your beautiful comments. So I hope you can see the result made by Vedantu in the previous years. In the 2000 JEE Advanced, you can see the rank 41, 38, 1, 697 with their names and photos. Okay, and what happened in the JEE Main, which happened some months before. Okay, 117 people from Vedantu who got above 99 percentile. Above 99 percentile. Now I hope you won't also miss a chance for your photo to come over here and to make your parents, yourself and this Vedantu proud, right? Okay, so try to be a part of Vedantu and to get beautiful and awesome results over here. And what I want to tell you is, if you are lacking behind with the courses, which means the schedules, and if you don't know how to make a course plan, and if you don't know how to make a proper revision of the previous year questions with a number of classes, 12th class crash course is already happening. And what do you want to do? What do you want to do? You just have to go to this particular link, apply this magical code. Once the magical code is being applied, which is AMECC, what will happen? The crash course which has to be there, or which has to be paid 12,000, this magical code, what you can see over here, will make it for 3,799.05. okay, good, happy. So don't forget to do this. It will help you a lot. As a teacher, I'm telling you, not as a person from Vedantu. It is going to help you a lot. So do this, make it awesome. So I hope you think that the class was awesome. So if you guys have understood, don't forget to hit the like button and share it with your friends if you think that the class was awesome and it was something informative and useful for you guys. And the last part is the best part, which you has to do to motivate us, to make us do more and more number of videos, to help you all. Okay, so for all these videos and for all this teaching, just what I'm asking from you guys is to hit this particular button which you can see, and for this it will be taking only seconds, right? 1 second, 2 seconds. So don't forget to do that before you leave the class. Just hit the subscribe button so I can come with so much of videos from JE Vedantu, and you'll get the notification for all the videos which is being uploaded by JE Vedantu, right? Guys, I hope you have enjoyed your Valentine's Day with Ameer Sir, right? By learning a lot much of physics. Okay, so don't worry, you will make an awesome future and we will rock it, right? So bye guys, see you tomorrow.